Our second keynote speaker is Dr. Joe Hitt. Dr. Hitt's the co-founder and CEO of GoX Labs and DARPA program manager for exoskeletons, humanoid robotics, guided bullets, and wearable technology. Dr. Hitt is an associate professor at the United States Military Academy, where he started a biometrics program. Dr. Hitt's presentation is going to talk about key predictors of injury, including fatigue, fitness, forces, form, and environment, and how wearables can collect accurate data regarding these predictors upstream to identify the risk per individual and their work environment. Dr. Hitt's presentation is entitled Impact of Wearables and Data on PtD. With that, let's run the video.
Hello, everybody. My name is Joe Hitt. I'm the CEO of GoX Labs, and I am here to talk about the impacts of wearables and data on prevention through design. So here is a quick concept on how I believe wearable technology can help with that. First and foremost, we are very good at measuring and identifying risks before they become injuries. And so you can imagine we can help then eliminate risk through design and so on. And over the course of the next 10 minutes or so, what I want to do is provide you a quick introduction to the technology we use at GoX Labs, and then 3 use cases where we measure, identify, substitute, or measure, identify, and redesign. First of all, our solution includes a smartwatch, a third-party smartwatch, connected by Bluetooth to a motion pod. With those 2 items, we can help predict illness before it becomes an illness, fatigue, heat stress, slips, trips, and falls, back sprains and injuries, shoulder sprains, injuries, ankle sprains, injuries, so on. Now, the purpose of what we're doing is to measure and identify these risks, develop mitigation strategies, and then prevent them. The key predictors of injuries are form, fatigue, force, fitness, and environment. To the left is a correlation mapping that we've developed over the course of the last 15 years that shows us that there are strong connections between, for example, form, the way you move in injuries, forces or the load you're carrying in injuries, your relative work rate or fatigue level and injury, fitness, and environment. And so what we do with the wearables is to measure these key injury predictors and then to prevent them before they become an injury. So how does the system work? Well, this motion pod can be placed on different parts of the body that are in question. If we're interested in looking at back injury risk, we would place it on the trunk. Shoulder injury risk, we would place it on the upper arm, and so on. We collect biomechanical information from the pod. It is sent by Bluetooth to the watch. Watch collects critical physiological information. And so when this physiological and biomechanical information is collected on the watch, we do the computation to understand its risk, and then we provide a green, amber, red risk score. We also aggregate all of the component risks, such as form, force, fatigue, environment, and so on, and provide this risk index. When connected by cellular or Wi-Fi to the server, this information is provided on any web-enabled device as a user view. You can so log in with your PIN and see your own views. The leader or a safety professional can see the group's view. And at the enterprise level, you can see enterprise information. Also, we can automatically set up text message alerts that can go to safety professionals and supervisors. So here is our first use case. This is a construction use case, primarily concrete work and cinder block work. And in this case, with our technology and mitigation strategies that we developed together with the client, we were able to reduce back injury risk by 26%, fatigue by 49%, and improve work fitness by 39%. We're able to do this by making small behavioral changes through education and encouragement on the ways they finish concrete, for example. By sweeping large sweeping motions near the red zone, your back is in a more precarious position, and the actual loads felt on the shoulder joint may be 10 pounds. But if you sweep closer to the body, it's at 5 pounds. So these small incremental changes allowed us to get these kind of improvements. And by the way, this use case we did with our partner, Everguard. And this is by group. So improvements in brick masons, cement masons, carpenters, and laborers. And you can see the total risk, torso risk, fatigue risk, heart rate, and dehydration. Dehydration really didn't improve much in this pilot, but we did see significant reduction in torso and fatigue. Here is a snapshot of one worker that we call the top gun, so the most improvement over a course of a 10-day period. And you can see that this orange line, which represents torso movement risk, dramatically dropped from about 70% risk all the way down to consistently below 10%. And by doing that, this blue line, which represents the overall risk score, also dropped from about 40% to 15%. All of the other risks stayed similar, such as dehydration, heart rate, fitness, so on. Now, at one point on day 10, fitness risk did spike to 55, and this is usually because of illness or severe reaction to allergies. And that was actually confirmed in this use case. This is a snapshot of 1 day of activity for a worker. In this case, it is that top gun that I spoke about. You can see that his heart rate is about 85 beats per minute throughout the day, which is nice. His fatigue level is below, so 30% of VO2 max, which is this green line, which is what we coach as low intensity, and that's where we would like them to be. Temperature during this day was 50 degrees Fahrenheit. Twisting movement was in the green zone, and bending movement was in the green zone. So overall, this worker on this date had a very low risk day. Second use case is regarding heat stress in a steel plant. And this is a pilot that's ongoing, so I'm only able to report on what we've measured and identified as the risks and our recommendations on changes they should make. So again, more education and substitution that I'll speak to shortly. So what we found when we placed a sensor inside these jackets was a heat index at one point peaked to 130 degrees Fahrenheit. We know that that is extremely dangerous and heat stroke likely. Heat index reached high levels even though the outside temperatures range from 60 degrees Fahrenheit to 75. And the key contributor to this heat index wasn't actually the temperature, but it was actually the humidity level. So that was a very interesting finding. And we know that humidity level reduces body's primary cooling mechanism, which is evaporative cooling. So redesign and substitute. So we want them to redesign the way they route their air so that they place the air very close to the worker, or maybe even provide portable forced air technology, such as pictured here, We want them to monitor physiological changes using wearables and implement notification technologies, such as the ones that we provide. And then consider vented and quick dry fabric outerwear, not cotton, which is basically what they use today, especially for the highest risk personnel. And we think that this could potentially reduce heat index by 20 degrees Fahrenheit. Here is one worker and his humidity level inside the jacket in blue. This orange line represents temperature inside the jacket, and then the gray is the heat index. So it's the combination of this temperature and this humidity level. And you can see at one point during this 9 a.m. to 4:30 p.m. shift, this heat index peaks at 129 degrees Fahrenheit, which is unacceptable. And our measurements occurred during March-April timeframe when the heat index was somewhere around 60 degrees Fahrenheit. And we know here in this location, their heat index, just outdoor heat index, will be 100 degrees Fahrenheit. That's a difference of 40 degrees Fahrenheit, and we don't really know what the impact of that is. However, we do know based on historical data that they have significant number of heat injuries during the summer months. This one is a very interesting use case where we had European agricultural workers picking lettuce, and we wanted to reduce back strain, so we introduced this exoskeleton called the Levo exoskeleton. And I'm going to show you this video of the lettuce workers at work. This worker is wearing an exoskeleton. The worker next to him is not. However, you can see that our technology or our pod is worn by workers with and without. So for example, on this worker with the striped shirt, you can see the pod on the shirt collar. And what were the results? Well, VO2, which is what we use for fatigue level or work exertion level, went down by 25%. The total number of lifts done, so number of times they picked lettuce, went up by 60%. Number of good lifts versus bad improved by 85%. Total of number of steps taken, so the number of steps taken as they were picking lettuce, increased by 70%. The bottom line was that exoskeleton reduced metabolic costs, enhanced lifting form, and increased productivity. With these results, this company widely deployed this exoskeleton. So in summary, wearable technology, I believe, can improve prevention through design by measuring and identifying risks upstream, providing this data-driven approach, and providing a closed-loop process where you can do the design, implement the design, and then measure and identify to see if those designs are effective. If you have additional questions, please contact me at hittjk@goxlabs.com. Thank you very much.
And thanks for that, Joe. And in addition to Joe's email that he provided there, if you have any questions near term, we'll field those after our last presentation.